Good afternoon, Miss Young here. This is a question from paper 42 from June 2022. I like to go and do these for the first time, having seen them the first time when I do the video, but I have to confess this time I did the video and then realised I hadn't turned my microphone on, and so I have to do it all over again. So I am coming into this with the benefit of having done it and having seen the mark scheme, but I'm going to show you the way that I went through it in the first place, and because I achieved 100% on the mark scheme, but I did also think of a slightly better way of doing things after I had finished. So we're going to do this question 1, and it says a program needs to use a stack data structure. So we know that a stack data structure is a last in, first out, and it clearly has a number of elements. One of the ways that we can implement a stack is using an array, and we can see here that in fact it is using a 1D array, and it's called stack data, and it's going to store the stack globally. The global variable stack pointer points to the next variable space in the stack and is initialized to 0. So we have two variables, stack data and stack pointer, and they're global. All global means is that they are initialized outside of any functions or procedures. So sometimes students will do something like global stack data equals, but there's absolutely the global keyword is for using inside a function or a procedure, or simply a def in Python. It's not used outside of a function, because by putting it outside of a function like we are doing here, it is automatically global. And now what it doesn't say is it needs to have 10 items and they need to be integers, but it doesn't tell us what they are. So I'm going to set them to be -1, because -1 usually indicates empty, and we want 10 of those. So we could do 10 of that, or if we really wanted to, we could do -1, and keep doing that. We've got 3, 4, 5, 6, 7, 8, 9, 10 of them, whichever way you prefer. That means you don't have to remember, but if you can't remember for list comprehension like that, then just do it like this. But I prefer to do it that way. You can choose. And then of course we have a stack pointer, and that needs to be initialized to 0. Again, it's a global by virtue of the fact that it's outside of any procedure or function, so there's no need to put the global keyword on there at all. And so what have we done? We've written the program code to declare the array and pointer as global data structures. Well, these are global data structures, and initialize the stack pointer to 0. So we've done that. And now we want to write a procedure to output all of the elements in the stack and the value of the stack pointer. So I'm going to, it doesn't tell us again what we should call this, so I'm going to call this def show stack data, and this doesn't take any parameters. And what do we need to do? Well, first of all, we're not going to be changing the value of stack data or stack pointer, so there's absolutely no need to declare them as global inside of this function. There's nothing wrong. You won't lose any points by going stack pointer and stack data, but there's literally absolutely no need. This will work just fine because we're not updating any values. So the first thing I want to do is print, and we're going to say stack pointer is at, and then we want to do stack pointer again. If you really want to use standard code, we can just copy this, and instead of using an F string, we just put at space plus stack pointer, whichever you prefer to do. But I prefer to use an F string, and there's nothing wrong with that. Then once we've done the stack pointer, I'm just going to print stack values, and then I'm going to go for I in range 10, and we can use 10. It's not going to be it would be better, of course, if you said max items is equal to 10, but this is such a small program that we won't do that. So what do we want to do? We want to say print index I, and then the value, which would be the stack data at I. And so that should be a correct function. Now it doesn't tell us to run that function, but we ought to, before we move on, check to see if that works. And we can see that index 0, the stack pointer is at 0, and the stack values, I'm just going to put a colon on here, these are the values at those positions. And then because I might want to print this out a second time, I'm just going to put a line like that, so we can see that we're at the end, in fact. Okay, and so that shows that that code is working, and so actually I'm going to keep that in because we may well need to use it later. So we now need to write a function called push, which takes an integer parameter and returns false. Well, let's come back to this first. It takes an integer parameter. So again, we could call this whatever we want, but this, given that it's in this particular font, means that we have to call it exactly that, and it takes something that we want to push. We can call it value to add or item. It doesn't really matter. It doesn't tell us what we need to call that integer parameter. So if the stack is full, how do we know if the stack is full? Well, because the stack pointer is 0, that doesn't mean that means the stack is empty. What it means is the next item we want to add to the stack will be at 0, and then so we know that when we add 9 items, that the stack pointer is going to be 10. So we can simply say if the stack pointer is equal to 10, then we want to return, and what does it want us to return? False. Now you could do an else here, but there's absolutely no point, because once it's returned, it will never get to this point if stack pointer is 10. So what do we need to do now? If the stack is not full, it puts the parameter onto the stack and updates the relevant pointer. Well, as soon as we know that it's updating, then we do need to use the global keyword, and we're going to be updating the stack data, and we're going to be updating the stack pointer. So we do need to have those. So we can say that the stack data at stack pointer is equal to the item, and then we need to increment the stack pointer. It really should be called free pointer in this particular case, because that's the one that is free, and we want to add 1 to that value. And in this particular case, what if we've got this far, then we want to return true, and that is the end of our function push. Relatively straightforward. This is just a simple pushing and popping from the specification. It says you need to know how to be able to add values to a stack and remove values from the stack, and how to do that using an algorithm. So this is a simple stack algorithm, push and pop, which are the two key functions in a stack. So let's just check that. It takes an integer parameter. It returns false if the stack is full. Well, if it's 10, that tells us the stack is full. If not, it puts the parameter value onto the stack and then increments the stack pointer and returns true. So we've done that perfectly. Now it says edit the main program. Well, this is the main program, but we need to do the main program after our functions. So what does it say to do? It allows the user to enter 11 numbers. Well, let's start with that. So if we want to enter 11 numbers, we're going to go for I in range 11 because we want to enter 11 numbers. And it doesn't say anything about validation, and you can see down here when we're going to test it, we're going to actually put real numbers in. So we can say something like number is equal to int, if I could type properly it would be great, int input, enter a number, and that does this, and then it attempts to add this to the stack, because we know if we can add it to the stack it returns true, and if not false. So we can say is added equals push, and we want to push that number to the stack. So that's an attempt to add it to the stack, and if it is added, well, then we can say, so if it is added, what do we want to do? We want to print successfully added to the stack. Otherwise, we want to print something like stack full not added, and that would be that. So it says output appropriate message when a number is added to the stack. We've done that. Output a message when a number is not added to the stack if it's full, and then output the contents of the stack, which is what this code is doing down here. I'll just remove the bookmark, and I'm just going to make that on here. So now, hopefully, what we should know is it's only got 10 items. So we've written this code, and we don't know if it's working at the moment because we haven't run this code. So what it tells us to do is we might as well use these for testing. We should know it should say return true or successful message for these first 10, and then an unsuccessful for the 21, and then it should just print 11 to 20 as the stack, and we know the stack pointer should be 10 because we will have added 10 items. So let's try and do that. Now, first thing I've noticed, you've no obligation to do it at all, but I'd like to put a colon on a space here so that we don't try and add spaces by accident. So we want 11 successful, 12 successful, 13 successful, 14 successful, 15 successful, 16 should be successful, 17, 18, 19, 20 should be successful, but then when we try to add 21, it should say stack full, not added. We can see the stack pointer is at 10 and the stack values are 11 through to 20. So we know that that is working just fine. So now we need to write another function called pop, and it takes no parameters. So we'll go back up to here and we will create a function called pop. And what does it do? If the stack is empty, well, we know that if the stack pointer is 0, then it is empty, so we should return -1. Then, as we return -1, we don't need an else, so we can just carry on and do what needs to be done. So if it's not empty, it returns the element at the top of the stack and updates the relevant pointer. Now, here's where I made the change that I pointed out, because in reality, what I told you is that the stack pointer will be 10, because that is the value at which, if you had enough elements, it would be where you would enter it. And the actual value that we want is at index 9. So the better way to do this, so there are two ways of doing this. We can say either, we can say item to return is equal to stack data at stack pointer, but it has to be -1. And then we can say stack pointer, change that by 1. Now, of course, because we're changing the stack pointer, we need to make that global. And you'll see that error message go away, or that squiggly line. The point is this: why should we find -1, take -1 off here, and then remove -1 here? It would be a lot simpler to take that off there, put it where it should be, and then take the item to return, and then we can just return item, going in camel case now, that's terrible of me. I'm just going to put item to return, and we can do return item to return. But of course, given that we've done it this way around, we can simply return that, and that would be the end of our function. And that works perfectly well. It returns -1 if the stack pointer is at 0. Otherwise, we decrement the stack pointer, because now we're going to be pointing to 9. That's where we want the next item to be added, and that's where the top of the stack currently is. So what do we need to do now? We've written the program code for pop. So after the code that we wrote down here, then we want to remove 2 elements from the stack using pop. Okay, so just we can do print. We know that it should return either the value or -1 if it's wrong, so we can print pop. We want to do that twice. We want to print the output from pop, and it should then say output the stack. Now, where a lot of students go wrong here is the stack itself should not change. We should still see 19 and 20, because we're not removing any data from the stack. We're simply moving the stack pointer back to 8 so that we've got 2 more items that we can add. So when we run this code, this first time it's going to show 11 to 20, but the stack pointer would be at 10. This second time it's still going to show 19 and 20 because we haven't removed the data. The whole point of the stack is that it's an efficient structure, an efficient abstract data structure. All we're doing is we're moving the stack pointer, and then when we next time we add an item, it simply overwrites what was there, but we know where the top of the stack is by the stack pointer, and so we always get the last value in the stack. But once the stack has been full, the data never changes until we update it. So we can pop all 10 items off the stack and it will still show us 11 to 20. So what we should see now when we run this, it should show pointer at 10, 11 to 20, and then pointer at 8, 11 to 20. So let's see if I am correct. And so we're going to enter again. We're going to go 11, 12, 13, 14, 15, 16, 17, oops, and we shall try again. And of course there's no way out of this routine, so we shall try running it again. So it was 11, 12, I'll be a bit more careful this time, 13, 14, 15, 16, 17, 18, 19, 20, and then of course we should see 21 not added. And so if we now take a look, what we should see is we added these numbers. When we added 21, it wasn't added. The stack pointer is at 10, and we have got 11 to 20. then we popped 20, and then we popped 19, which is what our demo, we didn't require that, we should just ask us to pop them. And then we can see that the stack pointer is now at 8, but we still have exactly the same data in the stack. And so now what I can do is I can simply change this to be pop. And now if I take a screenshot, well, if I was to run it again and take a screenshot, then we would have full marks for this question. And so there are many ways of doing this, but again, we can save ourselves some time with f-strings, we can save ourselves some time with list comprehension, and we can save ourselves, it doesn't really matter which way round you do it, whether you put -1, sorry, not there, that is important, you have to put that one this way round. Whereas this one here, you can either say stack value to return is at stack data at stack point -1, stack pointer is reduced by 1, and return value to return. But by doing it this way, you save a little bit of code and it makes more sense. And so hopefully that has helped you with this question. And I've been Miss Young. I hope to see you later. Thank you.